today we will learn that how a centrifugal compressor works. We will basically talk about the working principle of centrifugal compressor and its basic attributes. So over here these are the three diagrams which are in connection of centrifugal compressor. So first of all, to understand a centrifugal compressor, I will like to tell you an example for understanding. You would have observed that take some water in a tumbler and by the help of spoon stir the water. Over here the water is stirring. Okay, so you would have found that the water tries to go and stick with the peripheral surface, inner peripheral surface of the tumbler. The reason is that when we are rotating the water, when any body rotates about some axis, then it exerts a centrifugal force which pushes it in radial direction against the center, in the opposite direction of the center about which it is rotating. So same thing is happening in this container. When the fluid is rotating by the help of this rotating spoon, then a centrifugal force is developed. So that centrifugal force is forcing the water to go and stick with the inner surface of the tumbler. Same action is there inside a centrifugal compressor. So these are the components of centrifugal compressor. This first component which I am showing over here is the rotor. Rotor is also called as impeller. So impeller consists of its vanes. These red color entities are the vanes of impeller. Okay, and this entire rotor is mounted over its hub. This is the hub. You can say it as the axis about which this rotor rotates. And this is the casing. Okay, this is the casing, and casing consists of a nozzle. And over here I am particularly talking about centrifugal compressor, which compresses air, which takes air from the atmosphere and then compresses it. Now in this third picture, this impeller is sitting inside this casing. Okay, so this is the complete assembly, the schematic diagram of complete assembly of the centrifugal compressor. Now how it compresses? See, inside this casing this impeller rotates with high speed. Okay, so what happens? The air which is trapped between this space between these vanes, it also rotates with the impeller. So it exerts a centrifugal force on that air mass. So due to that centrifugal force, the air starts moving in radial direction away from the center and ultimately collects with high pressure in the volute of compressor. This final part over which, see, in this tumbler the water goes and sticks with the inner surface of tumbler. Similarly, in this casing, the place where ultimately the air goes in radial direction and collects, that region is called as volute of casing. So in the volute, high pressure air is collected, okay, and through a corresponding point the air goes out with high pressure and it is sent for use. Now when air goes out from the volute, it creates a vacancy inside. So that vacancy of air is fulfilled by entering of new fresh air from the atmosphere inside the casing. It is like this. So under a steady state, continuously the air goes inside, and by adding energy by this impeller to the air and due to centrifugal action, air goes to the volute and ultimately comes out from the outlet. So continuous airflow inside and continuous high pressure airflow goes outside through the volute from the corresponding point. So this is how a centrifugal compressor works. Okay, now in case we take the cut section of the centrifugal compressor, means by the help of this yellow plane I am cutting this compressor, then it looks like this. In this second picture I am showing, this is the impeller which consists of the vane. Okay, now, and this is the hub and this is the casing, and casing starts from the nozzle. Now you can see that after the impeller, see, when centrifugal force is developed in the air which is trapped between the space of this impeller vane, these impeller vanes, what happens that when it passes through the impeller, ultimately it reaches the diffuser and then to the volute. Now what is the purpose of this diffuser? See, what happens when the impeller rotates inside this casing, then air moves in radial direction due to centrifugal force. So what happens that during its movement, some amount of pressure rise takes place in the impeller itself. The reason is that you can see that when air is moving radially in radial direction, then the cross sectional area through which air is moving is continuously diverging. You can see. So this space between the impeller vane is acting as a diffuser. You know this thing, what is diffuser? Diffuser is that device through which when the gas passes, then its velocity decreases and pressure increases, and its action is just contrary to that of a nozzle. In nozzle, what happens? The cross sectional area decreases. So what happens? The pressure reduces and velocity increases. But in diffuser, what happens? The cross sectional area of the duct increases. So the velocity decreases and pressure increases. So that's what happens between the spaces of these impeller vanes. When air moves in radial direction, then the cross sectional area is continuously changing. So it is a sort of diverging cross sectional area. So some amount of pressure rise takes place in the impeller itself. Now still, if air contains some velocity, you know this thing, that we don't want kinetic energy of air, we don't want velocity of air, we need pressure. So what happens? Some pressure rise takes place in the impeller itself, and rest amount of pressure rise takes place in the diffuser. Okay, so diffuser is an empty space in which when air goes, then in the diffuser itself some amount of pressure rise takes place. So the normal practice is that when the air moves in radial direction, then 50% of pressure rise takes place in the impeller, and rest of the 50% pressure rise takes place in the diffuser, and ultimately in the volute high pressure air reaches. It's like this. Okay, now for the case of this centrifugal compressor, it could be of two type. One, that when air is entering inside through this nozzle, then it could be with inlet guide vanes, and it could be with no inlet guide vanes. What are inlet guide vanes? I will tell you later in this lecture itself. See, the centrifugal compressor could be of two type. One with inlet guide vanes, means after passing through the nozzle, it is facing the inlet guide vanes, and with vane diffuser and without vane diffuser. So once again, the centrifugal compressor could be with inlet guide vanes and vane diffuser, or it could be without inlet guide vanes and vaneless diffuser. Now what is the difference? In case of inlet guide vanes and vane diffuser, the efficiency of the compressor is more. In case inlet guide vanes and vane diffusers are used, then the amount of work done required to compress the air, same mass of compression, means in case we are comparing for same mass of air, then the compressor which has inlet guide vanes and vane diffuser, the efficiency is more, less amount of work done is required for that case. Okay, now how this inlet guide vanes and vane diffuser works? See, so over here we can see the diagram of a centrifugal compressor which contains the inlet guide vane set as well as the vane diffuser set. Okay, these dotted lines indicate that the existence of these inlet guide vanes and the vane diffuser is inside the casing. Okay, now what happens? Actually these are in case we talk about this inlet guide vane, then a vane is a sort of blade which is the part of the casing itself. Same with this vane diffuser, the vanes of vane diffusers are also a sort of blades which are the part of the casing itself. Okay, this brown colored body is actually the rotor or the impeller. It is like this. Okay, now what happens when air enters through the nozzle? Then they follows this guided path, because vanes are oriented with some direction. Okay, with corresponding direction they are oriented. So when air passes through these passages of vanes, then they are guided. So this flow of air is guided compared to that of in case we are not using any vane. So what is the benefit of this thing, guided flow? See, over here there is a conduit through which some fluid is flowing. So this conduit has a big cross sectional area. Now what happens when flow happens through big cross sectional area? Then there are chances of formation of eddies within the flow. Okay, when flow happens through a large cross sectional area, then there are chances that these rotational motion of fluid starts taking place, called as eddies. So it leads to loss of energy. Okay, and in this second picture, what is there? That there are vanes Okay, so this entire conduit is divided into number of fine passages. So in this case the air flows in guided fashion, so there is less space for the fluid to form eddies. So in this case the flow is more laminar and streamlined, so energy losses are less. So same case is there with this inlet guide vanes. When air flows through this guide mechanism, then the chances of formation of eddies are less, so it contributes to increment in efficiency of compressor. Similarly, when air passes through the nozzle, then passes through this inlet guide vane, and then ultimately passes through the impeller or the rotor, and when it exits from the rotor in radial direction, then it meets the vaned diffuser. Okay, so what is the benefit? Again, streamline flow. Over here I am showing you the passage between two vanes of vane diffuser. This is first vane, this is second vane. Okay, so when air passes through vane diffuser, again the flow is guided, so the chances of formations of eddies are less, so it again contributes to the increment of efficiency of the compressor. Now in case we talk about the type of impeller blades in a compressor, so these are the indicative diagrams you can see over here. So this is the casing, okay, and inside which the rotor is sitting. So there could be three types of impellers, rotor or impeller. One case is that the impeller vanes are perfectly radial. You can see the vanes or blades are oriented in radial direction from the center along the radius. So such type of impeller is called as impeller with radial vanes. Okay. Another case is that in case this rotor is rotating in clockwise direction, then the exterior tip of impeller vane is inclined in clockwise direction, inclined toward right in case it is rotating in clockwise direction. Such type of impeller is called as impeller with forward vanes. Similarly, in case the rotor is rotating in clockwise direction but the exterior tip of the guide vane is inclined in anti-clockwise direction, then such type of impeller is called as impeller with backward vanes. Okay, so hope you would have understood that what is a centrifugal compressor. So hope you would have understood what is a centrifugal compressor, its working, and the basic attributes in regards of centrifugal compressor. Thank you.